Hello. So last time we had learned about the standard integrals, the formula 1, 2, 3, 4, 5, 6, 7, 8, 9 above. Okay, so we had learned that we have so many formulas in the integration, and we had also learned the techniques, substitution, integration by parts. Today we will learn another technique, which is by using partial fractions. Okay, so this is base. Okay, we can do this when we are having polynomials. Okay, suppose when we are having integration polynomial divided by polynomial 1 divided by polynomial 2, the first polynomial, the second polynomial. This will work when we are having that degree of denominator, it is greater than degree of numerator. Okay, so whenever this condition is satisfied, then we can always use partial fractions. Okay, so let us just go ahead. This is based, since this one is based on polynomials, we will be needing constant polynomials, okay, linear polynomials, and also quadratic. If needed, we will also be requiring cubic or all those things, okay, power 4, power 5 polynomials, okay, that depends. So a constant polynomial, it will be of the form C, or we can simply write it as a constant A. A linear polynomial, it is of the form ax plus b, or simply we can write it as cx plus d, also doesn't matter. Okay, but we will be using ax plus b. Quadratic, it is of the form ax squared plus bx plus c. Cubic, similarly, we will be having plus bx squared plus cx plus d. Okay, so now that we know this one, what we will do is we will factorize the denominator. Okay, so if we have to use partial fractions, we first have to factorize the denominator. Okay, so since this one, it is a polynomial, so sometimes you will be having something that looks like this. Okay, you are having a linear polynomial times a linear polynomial. Okay, let us forget what the polynomial 1 is. Okay, but sometimes it is like this. Okay, we are concentrating only on the denominator. Then we will write this one in this way. So over here, I'll just write linear 1. And over here, this is the second linear. So I'll write plus linear 2. Since this one is linear, okay, linear will go down to a constant. We will drop the degree by 1. Okay, so it will be a constant A. So this one is also another linear. We will drop it to a constant. So it will be B. Okay, another constant B. I cannot use the same constants A and A. So I'm using another one, which is A. And over here, I'm choosing it as B. So this is when we are having linear. What if you are having 1 by linear square? It can also happen because you are factorizing the denominator. So this one, again, we will be having 1 by linear 1. But since this one is linear square, so I'll write over here linear square. And over here we'll still have B because it is still linear. Okay, so sometimes you can even have this one, linear. And over here you are having quadratic. What happens then? Okay, so what happens is, again, we will still write over here linear. And over here, I will write it as a quadratic. So the linear drops down to a constant. Linear drops down to a constant. So I'll write over here A. Quadratic drops down to a linear. So it will be bx plus c. Okay, again, I cannot use ax plus b anymore because I've already used the symbol A. Okay, so this is the technique. Similarly, if we have linear square quadratic, then we can do this one and then use the quadratic. Okay, so it's all based on the factors of the denominator. Once you know the factors of the denominator, then you can easily do partial fractions. Similarly over here, okay, let us just have another example. Maybe you are having linear cube. Then it will be A by linear plus B by linear square plus C by linear cube. Okay, you can simply do that. Okay, so this is the method of partial fractions. You will understand when we are doing examples, which I will do now. Okay, I will start up with a very easy one. Okay, maybe, okay, fine. I equal integration dx by x squared minus 5x plus 6. Okay, maybe let us make this one plus and over here minus. Okay, so now what we will do, if you remember the steps, we will first have to factorize the denominator. That is exactly what I will do. So if you factorize it, split the middle term, you will be having x plus 3 into x minus 2. Okay, so now what we will do, I will write this one as equation 1. Okay, let 1, okay, so over here this 1 by x plus 3, x minus 2 is equal to, now we will use partial fractions here. So over here this one, it is a linear, okay, power 1, x plus 3, this one is also another linear, x minus 2. So I have factorized it, then I've written the factors separately. Now you just see it is a linear since it is degree 1. So over here will have to be a constant. Again linear, so over here will have to be a constant. So this is what we are having. Now what will we do? We will multiply the whole thing by this denominator. So you'll be having this. Okay. Over here it is after multiplying by this denominator x plus 3, x minus 2. So what do we do next after multiplying? We will find the values of a and b. Okay, we need to find the values of a and b. They are constants, so we can find the values. How do we do that? Okay, we have two ways. One is by comparing the coefficients after multiplying, and another way is by putting particular values of x. This equation works for any x. Okay, so even for particular values of x, it will still work. Okay, so this is the technique that I will use, but I will choose x in such a way that this one becomes simpler. Okay, so that we don't have to do too many calculations. We can put any value of x in fact. Okay, but if you know how to choose them properly, you won't have to do too much calculations. Okay, so over here I will write here when x is equal to 2. Why am I choosing x is equal to 2? Because if you substitute it here, this one will become 0. Okay, so now substitute x equal to over there. Left hand side it's still 1. So this one becomes 0. X plus 3, which is 2 plus 3, which is 5. Okay, so it will be 5b. So if you find out the value of b, it will be 1 over 5. Next, I will put another value for x because I've only found the value of b. Now I need to find the value of a. When x is equal to, now I will choose minus 3. Okay, so if I choose minus 3, 1. So over here I will be having minus 5. Over here will become 0. So a will be minus 1 by 5. Okay, after finding the value of a and b, yeah, I'll just note it down here because I will have to erase it. After finding these values, now I will substitute this equation 2 in equation 1. Okay, you notice that this one can be replaced, okay, this whole thing can be replaced by equation 2. Okay, so if we do that, we will be having this a divided by x plus 3 plus b divided by x minus 2, and over here we will be having dx. Okay, so this is what we have. Okay, so over here we can actually substitute the values of a and we can substitute the values of b. we can do that, we can substitute it right now, but I don't usually do it in that way. What I usually do is I will just evaluate the integral, and then afterwards I will put the value of a and b, okay, which is equally valid. Okay, so now let us just integrate, split them, okay, and then integrate. Again, a it is a constant, we can take it outside. B it is a constant, we can take it outside. So over here we'll be having log x plus 3 if you integrate it, and over here if you integrate it you will be having log x minus 2. Okay, and then over here, since everything is log, okay, remember that we have to put a constant c. Okay, but we can actually do better over here. We can simply put down log c. Okay, we can do this. Now what I will do, I will put the value of a. Since now there is no longer any integration sign, we can simply put down the values of a. So the values of a it is minus 1 by 5. The value of b it is 1 by 5. Okay, so we can do it. Okay, now what I will do, I will write log, then put this power over there, x plus 3 power minus 1 by 5 log x minus 2, okay, properties of logarithm, plus log c. Okay, log a plus log b plus log c will be log x plus 3 power minus 1 by 5 times x minus 2 power 1 by 5 into c. Okay, so this is the final answer. There is still this constant. Okay, so this is the final answer. Okay, some of you may be wondering, how did I know that integration of this one is equal to log? For that, you can check out the integration videos that I've posted in the integration playlist. Okay, so make sure to check out the playlist in case you don't know how the integration becomes log. All right. Okay, so that is the first example. Now let us do another example. Okay, will be slightly difficult. I it's equal to 2x plus 1 upon x cubed plus x squared minus 2x. Okay, so now we need to integrate that. Again, remember that the first step is factorizing the denominator. Okay, so we don't care what the numerator is. Now we will factorize it. You will be having this. Again, we can still factorize this one, okay, which we can do, which we can split the middle term. You can factorize it by splitting the middle term. You will be having this x minus 2, x plus 2 and x minus 1. Okay, so if you factorize this one, it becomes like this. Now, okay, now what will we do? We don't care about what this is. All right, but we will write it as 1. Okay, so what we can do, this thing 1 divided by x plus 2, x minus 1. We will use partial fractions now. So we will just write x plus 2. We are having 3 factors and x minus 1. Again, this one it is a linear polynomial because it is of degree 1. So over here I will write down a constant. Linear constant, linear constant. So this is what we are having. Next I will multiply the whole thing by this denominator. Okay, multiply by this. You will be having this. Okay, b x into x minus 1 plus c x into x plus 2. So now we need to find out the value of a, b and c again. Now we will just substitute some particular values of x. When x is equal to, okay, let us choose. Okay, x is equal to 2. When x is equal to 2, then so this one will become 0. Okay, actually we can choose x equal minus 2. Okay, because if we choose x equal minus 2, then this one and this one will become 0 when x is equal to minus 2. So this one becomes 1. X is equal to minus 2, so this one becomes 0. So this whole term becomes 0. Over here we'll be having plus minus 2b. Minus 2 minus 1 will give you minus 3. And this one becomes 0 because x is equal to minus 2. Okay, so we can easily find out what b is. It will be 1 upon 6. Now we can put the value of x is equal to 0. Okay, let us put x is equal to 0. If you put x is equal to 0, over here will be 0. Over here also will be 0. So all that is left is this. So again, 1 will be equal to a. X plus 1, x plus 2 will be 0 plus 2, which is 2. 2 and over here minus 2. Over here will become 0. Over here will become 0. So a, it will be minus 1 by 4. So this is what we are having. Now let us put another value of x. Okay, we can simply put the value of x equal to 2. Okay, we can do it. We can do it with any value, in fact. Okay, we can even do it with 1. It doesn't really matter. Okay, so let us choose. Okay, we can choose any value over here. Okay, as long as okay, we can choose any value, but let us choose the smallest one that will make our calculation easier. So I can easily put x is equal to sorry, okay, I made a mistake somewhere. This one should be minus 1. Okay, this one should be minus 1. Okay, so I don't think will affect this choice. Okay, and over here I think over here it should be minus 1. Okay, so over here will be a equal minus 1 by 2. Okay, now let us choose another value. We can choose x is equal to 1. Okay, so when we choose x is equal to 1, over here will be 1. Over here will be 0. Now this second term will also be 0. The third term will be c. Over here will be 1. So it will be 3. C, it will be 1 by 3. Again, what I can do, I can note down the values. B is equal to, right? B, it's equal to 1 by 6. And C, it's equal to 1 by 3. Again, what I will do, I will substitute this equation 2 in equation 1. Okay, so substituting 2 in equation 1, we will be having I. So this whole thing, it's being substituted. 2x plus 1 still remains. 2x plus 1. And we will be having a by x plus b by x plus 2 plus c upon x minus 1 dx. So this is what we are having. Next, what I will do, okay, I can split. Okay, again, I won't put the values of a and b and c. That will be too confusing. So I can write it like this. 2x plus 1 upon x plus 2. And over here I will write plus c. 2x plus 1 upon x minus 1 dx. Okay, so now we can easily integrate this. Okay, how will I do it? You notice that the first one, it's relatively easier. Okay, you can just write it as 2, split it. You will be having this. Now for this one, how will I do it? I can choose x plus 2 equal t. Okay, so for the second one, that x plus 2 equal t. And for the third one, I will choose x minus 1 equal z. Okay, so you will be having Okay, you will be having x equal t minus 2, and over here you will be having x equal z plus 1, and if you differentiate it, you will be having dx equal dt. Okay, and if you differentiate this one again, you will be having dx equal dz. So this is what we are having. Okay, the first integral can be easily evaluated. Integration 2 will give you 2x. Integration 1 by x will give you log x. Okay, now we need this one, b. So 2x will give you 2, t minus 2 plus 1. So over here this dx, so it has been changed into dt. X plus 2, it's t, dt plus c. Over here it will be 2 times z plus 1 plus 1, x minus 1, it is z. Dx has been changed into dz. So now what I will do, I will write 2t. 2 into minus 2 will give minus 4. Minus 4 plus 1 will give you minus 3 upon t plus c 2z plus 3 upon z dz. So this is what we are having. Okay, now we can do the integration easily. Okay, I will skip a few steps. I will write down the answer directly. So over here will be b. Okay, so split this integral, you will be having 2t minus 3 log t. Okay, so I'm skipping one line. Okay, I hope that you can fill it. Plus c. Over here we'll be having 2z plus 3 log z. Okay, and I can also put down another constant, which is plus. So I've used a, b, and c. I can put d. Okay, d, it is a constant of integration. So since this is done, I can now substitute the value of a. A will be minus 1 by 2. B, it is 1 by 6. And c, it is 1 by 3. Okay, now what I will do next, I can substitute the values of t from over here. T will be x plus 2. Substitute it there. And similarly, substitute the value of z equal x minus 1 over there. Okay, so you can write it in this line. That will be the final answer. So I hope that is clear. Okay, what I will do now is another problem. So the first two problems, you notice that only linear factors are involved. Okay, now what I will do the problem which involves quadratic. Okay, so let's see the third one. Okay, I will do this. Again, the first step, it is factorizing the denominator. This one, it is a cube plus b cube. Okay, so we can write it as x plus 1, x squared minus x plus 1. Okay, a cube minus b cube. If you don't remember, it is a plus b, a squared minus ab plus b squared. Okay, so that is what I've written over here, dx. This one we cannot factorize anymore. Okay, so before we can factorize it, but now we can no longer do it, so we will leave it as it is. If you can still factorize it, then do factorize. Okay, so now so this jumps directly to this step. 1 upon x plus 1, x squared minus x plus 1. So this one, it will be equal to 1. So sorry, it will be a, because over here it is linear, so over here will be constant. Now you are having this quadratic. This is a quadratic, so over here will be a constant, bx plus c. Again, the same step, multiply by this denominator, you will be having this. bx plus c, and you will be having over here this one, x plus 1, x squared minus x plus 1. Okay, so this is what we are having. Now we just need to find the values of a, b, and c. Again, the same thing. When x is equal to minus 1, okay, if we choose minus 1, then this whole thing becomes 0. Then we will be getting 1 minus 1, okay, so it will be 1 plus 1 plus 1, right? And over here will be 0. So a will be equal to 1 by 3. Okay, now we can substitute the value of x equal to 0, because if we put x is equal to 0, then this one will become 0. Okay, the b term will not be involved. When x is equal to 0, so you will be having 1. 0 minus 0 plus 1 will give you a. B into 0 will give you 0, so you will only be having c. 0 plus 1 will give you 1. Okay, so c, it will be 1 minus a, 1 minus 1 by 3. So you'll be having 2 by 3. Okay, a, it's 1 by 3 from this first line. Okay, now we can choose another value of x. Okay, we can put x is equal to 1. Let us see. Again, over here we can do it with any value. Okay, but let us put smaller values. That will always be simpler. So 1 square minus 1 plus 1 plus b plus c, and over here 1 plus 1 will give you 2. So it will be a plus 2b plus 2c. We have already found c. So 1, here it is 1 by 3. 2b, 2c will give you 4 by 3. So 1 equal 5 by 3 plus 2b. I really hope that I did not make any mistake, but if I did, then you can do the corrections. 2b, it will be 1 minus 5 by 3. 1 minus 5 by 3 will give you minus 2 by 3. So b, it will be minus 1 by 3. Okay, so this is what we are having. Okay, so I'll just note down the values. B, it is minus 1 by 3, and C, it is 2 by 3. Again, we can substitute equation 2 in 1. Okay, if we do it, then we will be having this. Okay, so if we substitute 2 in 1, then it will be integration a upon x plus 1 dx plus bx plus c upon x squared minus x plus 1 dx. Okay, so now, okay, this one can be easily calculated. So you will be having a log x plus 1. Now, how do we integrate this one? Okay, so remember that now we are having a quadratic, and on top we are having a linear. So remember the rules last time when we were doing standard integrals. So that is when we will have to use it again over here. So this one is about linear divided by quadratic. Okay, so now we will have to use standard integrals. Again, check the playlist about standard integrals, okay, which I will keep it in the playlist. Okay, so now we will do it. Actually, over here now it becomes, okay, since we cannot do this integration directly, now we will have to put down the values of b and c first. Okay, that will be simpler. So b, it is minus 1 by 3, and c, it is 2 by 3. x square minus x plus 1 dx. Okay, so over here a also I can write it as 1 by 3. Okay, since I've already substituted, okay, so I will be having 1 by 3, and over here I will be having minus x plus 2 x square minus x plus 1 dx. So this is what I will be having. Now, how will I evaluate this integration? If you remember, I will have to substitute z, okay, this whole thing to be equal to this denominator equal to z. Then I will have to differentiate it. If I differentiate it, I will be getting 2x minus 1 dx equal to dz. Now here comes the tricky part. I will have to get 2x minus 1 in the numerator. So over here I will be getting, I can multiply the whole thing by minus 2. Okay, I can multiply the whole thing by minus 2. So you'll be having 2x minus 4. But since I multiply by minus 2, so over here also I will divide by minus 2. Multiply and dividing by minus 2. Okay, so this is what we are having. So now this one will become minus 1 by 6. And notice that we need 2x minus 1. But over here I can simply write it down. Minus 4 minus 3. 2x square minus x plus 1 dx. Okay, so I will keep it as this. I am doing all this so that I am getting 2x minus 1 in the numerator. Okay, so this one will be 1 by 3 log x plus 1. I will just have to keep on writing it. Minus 1 by 6. Now we can split the integral. Integral 2x minus 1 dx upon x square minus x plus 1. And I will be getting minus 3 integral dx upon x squared minus x plus 1. So this is what I will be having. So how exactly do we evaluate this first integral? Okay, so this one just substitute. So you will be having 2x minus 1 dx will become dz. And this one has become z. And what about this second integral? This second integral, we will have to complete the squares. Okay, again, you can refer why we are doing it in that way by checking the video on standard integrals in the playlist. Okay, so I've already used these values. I won't be needing it anymore. So minus 3. Okay, so now let us complete the squares. X squared minus 2 x 1 by 2. So you'll be needing 1 by 2 whole thing square minus 1 by 2 whole thing square plus 1. Okay, so this is how we complete the squares. Again, check the video last time on standard integrals. Okay, so minus 1 by 6 log z. Minus 6 minus 3 will give you plus 1 by 2 dx. This one you can write it as x minus 1 by 2 whole thing square. And this one you will be getting, okay, minus 1 by 4 plus 1. Okay, you will be having minus 3 by 4. So this is what we are having. But now we will have to use the standard integrals. Okay, if you check, okay, it is similar to number 2. Okay, so if you check, it is similar to number 2, x squared minus a squared. X squared minus a squared. So what will we do now? We will have, this is already a square, so we have to express this one as a square. So we can write it as square root 3 by 2 whole thing square. Okay, so this is what we are having. Plus 1 by 2. And if you use formula number 2, okay, let me just expand it. You'll be having 1 by 2a. So 1 by 2. So this one will be a square root 3 upon 2 log x minus a, x minus 1 by 2 minus a upon x plus a. So this whole thing behaves as x plus root 3 upon 2. Okay, so this is what we are having. We can again put the value of z. Here will be plus the constant c. Okay, I'll write d. Okay, since I've already used the constant c somewhere else, so I'll write it as plus d. Z, it is x squared minus x plus 1. Over here we'll be having 1 by 2 root 3. Okay, log. We can do some simplification. Okay, 2x minus 1 minus root 3 upon 2x minus 1 plus root 3 plus d. Okay, so no more integration sign, so that is why this one will be the answer. Okay, so we have done something that involves a quadratic. Okay, now let us do the last question, which involves linear square. Okay, okay, I'll just write it down. X squared. Okay, maybe I'll write it like this. X plus 1. And maybe over here, x minus 1 whole thing square. Okay, so again, this one we won't worry. We won't worry what the numerator is. Also, substitution will not make the numerator disappear. Okay, sometimes numerator will disappear by substitution, but over here it won't. Okay, but again, no problem. Okay, so this has already been factorized, so I will write 1 divided by x plus 1, x minus 1 whole thing square. So this one there will be 3 factors, 1, and over here 2 factors. So the first factor and the second factor will be the square. Okay, so over here this one is linear. Again, over here will be constant, 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 because all of them are linear factors. Now again we will multiply the whole thing by, okay, so we'll be getting 1 x minus 1 whole thing square plus b, you'll be having x plus 1 to x minus 1 plus c into x plus 1. Okay, so this is what we will be having. So comes this part. So now we will substitute x is equal to 1. It will become 0. It will become 0. Over here will be 2c. So you'll be getting c equal 1 by 2. Now we put x equal to minus 1. If we put x equal to minus 1, so we will be getting 1. Okay, so over here we'll be getting, okay, we put x equal minus 1, so this one will be getting a minus 2 whole thing square. This one will become 0. This one will become 0. So a, it will be equal to 1 upon 4. Now we can put another value. Okay, we can choose any value that we like. Okay, since we have not used 0, let us just put 0. So you will be getting, the left hand side is 1. So you will be getting a. You will be getting minus b. Okay, you can do this 0 plus 1, 0 minus 1. So minus b plus c. We need the value of b. So b, it will be a plus c minus 1, 1 plus by 4 plus 1 by 2 minus 1, 4, okay, take the LCM, 1 plus 2 minus 4 minus 1 upon 4. Again, let me just note down the values. B, it's equal to minus 1 by 4, and C, it's equal to 1 by 2. Okay, so these are the values that we got. So substituting 2 in 1, okay, substituting 2 in 1, you will be having this, okay, I equal integration of this whole thing. But remember that there was that x square, okay, so again over here we'll be having this, okay, and over here we'll be having dx. Okay, so this is what we are having. So now we can simply write this one like this. So the first and the second term won't pose any problem. Okay, we will be having x squared by x plus 1 dx plus b x squared by x minus 1 dx plus c x squared by x minus 1 whole thing square dx. Okay, so this one we can substitute x plus 1 equal t. Okay, this one we can substitute x minus 1 equal to, okay, let us say z. But how will we integrate this one? Okay, how will we integrate this? All right, so notice that this one can actually be written as x by x minus 1 whole thing square. Okay, so again over here we will do the substitution x minus 1 equal to z. Okay, so similarly over here we will do the same substitution, which is x minus 1 equal to z. So over here we'll be having dx equal dt, dx equal dz for these two. Now over here we will change x squared, it will be t minus 1 whole thing square, because x it will be t minus 1 divided by x plus 1, which is t dt. X minus 1 will be z, so x it will be z minus z plus 1, and over here will be c, again x will be z plus 1 whole thing square, x minus 1 will be z square. Dx has been changed to dz. Okay, so this is what we are having. Okay, okay, so I erased the value of a, b, and c. Okay, but anyways, you can always substitute it at the end. Okay, you just need to remember what they are. Now this one, how will we integrate it? Okay, we just square this one. It will be t squared minus 2t plus 1 upon t dt plus b z squared plus 2z plus 1 upon z dz plus c integral z squared plus 2z plus 1, okay, by z squared, okay, dz. Okay, so now the integration becomes simpler. Okay, just split it. So over here will be integration t minus 2 plus 1 by t dt plus b z plus 2 plus 1 by z dz. Okay, remember the substitutions. Okay, you will have to substitute them back again. So over here will be 1 plus 2 by z plus z power minus 2 dz. Okay, so let me complete it, and then you will have to substitute the values on your own. So over here will be a t square upon 2 minus 2t plus log t plus b. Over here you will be having z square upon 2 plus 2z plus log z, and over here you will be having c, okay, integration of 1, which is z plus 2 log z, and over here you will be having z power minus 1 divided by minus 1, okay, plus you will be needing another constant, which is d. Okay, so substitute the values of a, b, and c, substitute the value of t, substitute the value of z, change everything back into x. That will be the final answer. Until next time.